grade 4s, and I hope that you are having an absolutely wonderful morning so far. I hope you had a great night last night where you were able to get some relaxing in, maybe play a board game with some family members, go for a walk, just get outside and smell the fresh air, something it's so important to do during these difficult times. I know for me, once I finished school yesterday, I went for a nice long walk all around my neighborhood. It was fantastic getting that exercise, moving my body, getting out of this house, which is beginning to feel a little bit like a prison for me, and just smelling that fresh air. So remember, take these opportunities just to do the little things to remind us that we're human and to get us out of our house, to just change up the norm a bit, to change it up. It's a good thing to do. Speaking of changing it up, we're going to be changing up how we do our multiplication today. So, in the past, we've done the standard algorithm. We've looked at the breaking it apart method and solving it with FOIL. Now today, we're going to look at multiplication being solved using the window technique. Again, these are all different techniques, different toolboxes, different tools in the toolbox to solve the same problem. They all give you the same answer. For some people, it might be a really handy-dandy tool that is efficient for them and gets the work done quick. For others, it's just not a tool that makes sense to them, and you don't want to use it, and that's perfectly okay. But it's important for you to know about the tool in case you want to use it down the road. So let's get in to how to solve multiplication problems using the window technique. Let's look at the window technique. First thing we need to do is start off with a problem. Let's do 25 times 6. Much like the other technique, we are going to start off by putting 25 into its expanded form. So let's just do that on the side here. 25 would become 20 plus 5. Why does it become 20 plus 5? Because there's 2 in the tens column, which makes it 20, and there's 5 in the ones columns. So 20 and 5. Now, the next thing that we're going to do is a little bit different. We're going to draw a picture. And it's going to be of a window. We've got our handy-dandy window right here. It's such a beautiful window. Look at that beautiful window. I've said it before, I truly am an artist. Not. So now what I'm going to do is I'm going to put our 20 here. I'm going to put our 5 here. And I'm going to put our 6 right here. So here's our 20 and 5. 25 times 6. And there's our 6. So the 25 is on the top. And the 6 is on the side. Now, it doesn't matter if you put the 25 here and the 6 here. That doesn't matter at all because, as you know, math is commutative. Yeah? So, how do we solve this? Well, the first thing that we're going to do is, what is 20 times 6? We're going to work on doing these ones first. 20 times 6 is 100. And 20. Again, I use my handy-dandy life hack. I know what 6 times 2 is, and I add a 0. 6 times 2 is 12. Add a 0. Next off, 6 plus 5 is 30. Now all I do is I add these up. 120 plus 30 is 150. Now you might be wondering why I have these two window panes here. That's actually for when we get into double digit by double digit. So I'm just setting it up that way today so that when it comes time for tomorrow, you're like, that makes sense. Let's real quickly see if 25 times 6 is the same using the standard algorithm. All right, so for 25 times 6, we start with the ones column. 6 times 5 is 30. Put the 0 there. Carry over the 3. 6 times 2 is 12. Plus 3 is 15. 25 times 6 is 150 using the standard algorithm. All right, let's start off with, oh, need to get my pen. Let's look at 37 times 9. Okay. Our first thing that we're going to do is put 37 into expanded form, which becomes 30 plus 7. 9 is already in its expanded form. There's 9 in the ones column. Next thing we're going to do is make our beautiful window pane. Look at that beautiful window pane. I am such an artist. Not. I couldn't even draw a stick man if my life depended on it. Alright, so I'm going to put, just to show you guys that it works no matter which way you do it, because math is commutative, I put the 37 on the top last time, the double digit on the top. This time, I'll do it on the side. Just that you can see, oh yeah, it doesn't make a difference. Yeah. 37 times 9. 37, 37, 9, 9. 37 times 9. I'm going to start off with this window here. And this is a wonderful thing about this method. With the standard algorithm, you must start with the ones columns. But check it out. I could start right here if I want. It makes no difference. 7 times 9, 63. Now I can go on to the next one. 3 times 9, 27, plus 0, 270. You see, it doesn't matter what window pane I start with. It all equals the same thing in the end. Add up my window panes. 0 plus 3 is 3. 7 plus 6 is 13. Carry over the 1. 1 plus 2 is 3. 37 times 9 is 333, according to the window method. Let's see if we're correct here. 9 times 7 is 3. Carry over the 6. 9 times 3 is 27. Plus 6 is 33. No matter what method we use, it still equals 333. Let's look at one more double-digit number, and then we're going to get into a triple digit by a single digit. Let's look at 43 times 8. First thing we need to do is put 43 into its expanded form. 40 plus 3. Next off, we make our window. For our window, we're going to put 40 and 3 here. Again, doesn't matter which way you put it. I'll put the 6 here. You can put the 40 and 3 on the lengthwise or the widthwise. It doesn't matter as long as you got 43 by 6 or 43 by 6. Doesn't matter. Math is commutative. 6 times 40 is 240. I know that because of my life hack. 6 times 4 is 24. Add a 0, 240. Next, 6 times 3 is 18. Now I add these up. 240 plus 18. 0 plus 8 equals 8. 1 plus 4 equals 5. 2 plus nothing equals 2. 43 multiplied by 6 equals 258. All right, let's look at one example, or let's look at this example using the standard algorithm to see if it matches up. 8 times 3. Oh, I just realized that's not the same. Let me just fix that. Dope. Fail. That should say 6. Look at Mr. Merrick. Oh my goodness, Mr. Merrick! This is what happens when you do these lessons at like 5:45 and you're a little tired still. You make little mistakes. Alright, now that we have the same multiplication equation, believe it or not, that's important. 6 times 3, 18. Carry over the 1. 6 times 4, 24, plus 1, 25. They are the same answer. 43 times 6 is 258, whether you use standard algorithm or the window method. All right, now we're going to get into some triple digit multiplication. Let's go 153 times 2. Yeah. First thing we got to do is get this into expanded form. That would be 100 plus 50 plus 3. Now let's make our window. This is probably my worst window yet. I'm not good at making windows. It's a good thing I'm a teacher, not a construction worker. My house would fall down. All right. Now that we got it set up, we have our 153 right here. And there's our 153 with the standard algorithm. Next off, we have our 2 right here and our 2 right here. 153 multiplied by 2. 100 times 2 is 200. 50 times 2, 100. 3 times 2 is 6. I can add them up on the side if that makes it easier for you. 200 plus 100 plus 6. 0 plus 0 is 6. 0 plus 0 is 0. 2 plus 1 is 3. According to the window method, 153 multiplied by 2 is 306. Let's check with the standard algorithm now. 2 times 3 is 6. 2 times 5 is 10. We carry over the 1. 2 times 1 is 2. Plus 1 is 3. 306. 306. Let's do one more triple digit, and then you guys can get to the lesson. Let's take a difficult one. 987 multiplied by 6. This is going to be tough. First thing we're going to do is break up 987 into expanded form. 900 plus 80 plus 7. Going to make our window. Hopefully this window isn't as awful as my previous one. Don't hold your breath. Mr. Merrick does not do art. Not even stickmen. You should know that. Alright, now we're going to set it up. Our 900 on the top, but you could put it on the side if you wanted. You'd have to adjust how you do your window, because math is commutative. And now I'm going to multiply by 6. Alright, first one. 900 times 6. Well, as I've mentioned before, let's use our life hack. Instead of doing 900 times 6, let's just do 9 times 6. 9 times 6 is 54. Oh, but look, there's 2 zeros here, so I add 2 zeros. 8 times 6 is 48. But there's a 0 there. I add the 0. 6 times 7 is 42. No zeros, don't need to add any zeros. Now I add all of these up. 5,400 plus 480 plus 42. 0 plus 0 plus 2 is 2. 0 plus 8 plus 4 is 12. Carry over the 1. 1 plus 4 plus 4 is 9. 5 plus nothing is 5. According to the window method, 987 times 6 is 5,922. Let's see if we get the same answer using the standard algorithm. I suspect we will, because I'm noticing a pattern. 6 times 7 is 42. Put the 2 Put the 2 right here. Carry over the 4. 6 times 8 is 48. Plus 2 is 52. Carry over the 5. 9 times 6 is 54. Plus 5 is 59. Using the standard algorithm, we get 5,922. And using the window method, we get 5,922. I want to know, what technique do you like best? In your toolbox, what tool helps you solve multiplication problems most effectively? Put it in the comments. I'm really curious. I want to know. For me, it's always been the standard algorithm because that's what I use. As a kid, that's what I was raised on. But if I'm being honest with you, I actually find this method to be easiest to solve. And I find the FOIL method the best method to help prepare you for when you need to do algebra later on. 3 different methods. They're all going to help you with things as you go along your math journey. But at the moment, I want to know which one is most effective for you. Put it in the comment section. Have a great day, and don't forget, we have our conferences tomorrow, and I look forward to seeing everyone. And in our conferences, I'm not going to remind you, if you tell me what math technique you prefer to use, all you need to do in our morning circles, tell me what tool you like in your toolbox the best for multiplication. I'm going to add you to the chocolate bar / bag of candy list. That's all you got to do to earn yourself a chocolate bar or bag of candy. Have a wonderful day, everyone. Bye.